Drag the correct equation to each graph. Study the graphs carefully. So to graph these, we use inputs of -1, 0, and 1. So let's determine the points that would match for each equation and then find the graph that goes along with it. So input a -1, 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the 1 is 2. So let's take a look and see which graph that looks like. So it looks like graph, well, let's number these 1, 2, 3, and 4. So this one, y equals 2 to the x, looks like graph number 4. Now y equals 2 to the -x, inputs of -1, 0, and 1. 2 to the negative of -1, that's 2 to the 1 or 2. 2 to the 0 is 1. And then 2 to the -1, that's 1/2. By the way, if you wanted to when you got started, for this particular function, you could have written it like this. You could have written it as y equals 1/2 to the x power. Do the reciprocal, make the power positive, and you could do it that way too. But anyway, this one looks like graph number 2. Y equals 3 to the x, inputs of -1, 0, and 1. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. So which graph looks like it has that? Looks like graph number 1. And then y equals 1/3 to the x, inputs of -1, 0, and 1. Output, y equals 1/3 to the x. Well, if you input a -1, that does a reciprocal of 1/3, which is 3. 1/3 to the 0 power is 1, and 1/3 to the 1 power is 1/3. So -1, 3, 0, 1, 1 and 1/3. That looks like graph number 3. So you can use the 3 inputs to determine the 3 important points that are on the graph, and by examining the graphs, you can determine which equation goes with which graph.